Welcome to this explainer. Today we're tracking exactly how code securely travels from a developer's machine all the way to a live Kubernetes cluster. I am absolutely thrilled to guide you through this end-to-end journey. We aren't just looking at the tools, though. We're going laser-focused on the handshakes, the secret exchanges, and the strict authentication protocols that keep your application safe at every single hop. But before we get into the right way to do things, we have to talk about the elephant in the room. Who actually has time for security anyway, right? It's a super common, but frankly dangerous mindset. When we're rushing to ship features, security often gets pushed to the back burner. And neglecting security in your deployment pipeline doesn't just mean a minor bug might slip through. It can lead to absolute disaster for your entire infrastructure.
And here is exactly what's at stake. Think about it. When systems like Jenkins are exposed with poor authentication, attackers don't just see what you're working on. They literally get the keys to the kingdom. They gain the power to instantly destroy production environments, leak deployment credentials, or completely steal your entire code base.
So to make sure that never happens to you, today's agenda covers 1. The vulnerable CI/CD pipeline, 2. First hops, developer to build, 3. Securing artifacts in Harbor, 4. ArgoCD, the GitOps poll, and finally, 5. Safe deployment in Kubernetes.
Okay, let's jump straight into section 1, the vulnerable CI/CD pipeline. We're going to examine the weak links.
Imagine looking at a pipeline script and seeing a user and password sitting right there, completely in the open. Leaving plain text credentials lying around like this is pretty much the ultimate security flaw. If this gets logged anywhere, or if anyone just glances at the repository, your system is instantly compromised. No way around it. Proper credential management means treating every single authentication step like a strict VIP ID check. You never, ever expose credentials in your build logs or pipeline scripts. Instead, you've got to store these secrets safely within the tool's dedicated vaults, like the Jenkins credential storage feature. And of course, always follow the principle of least privilege. Only give users and systems the exact permissions they absolutely need.
To fix those vulnerabilities, we use what's called the GitOps chain of trust. Think of it like a relay race. We're securely passing the code commit like a baton through 4 distinct phases: dev to Git, Git to Jenkins, Jenkins to Harbor, and ArgoCD to Kubernetes. And at every single handoff, we require cryptographic proof of identity.
Moving on to section 2, first hops, developer to build. Let's look at those initial trust handshakes. So here's where the strict handshakes actually begin. Hop 1, the developer securely authenticates to CATIA using their personal SSH key pair. It's heavily encrypted, identity verified, and completely passwordless. Then, hop 2. Once CATIA accepts that code, it triggers Jenkins via a webhook, which is authenticated using a secure password. Finally, when Jenkins is ready to grab that new code, it uses its own dedicated SSH key pair to securely pull the repository directly from CATIA. Just to quickly clarify that middle step, a webhook post request is basically just a secure automated notification payload sent by CATIA. It tells external systems like Jenkins that a new change was just made. It's a secure trigger, so Jenkins knows exactly when to pull the repo using those stored SSH credentials. Section 3, securing artifacts in Harbor. This is all about safe storage for your container images.
That brings us to hop 3. Jenkins has built our app into a container, and now it needs to perform a handshake with Harbor, our container registry. Jenkins securely logs in using specific user and password credentials provisioned just for this exact task. It proves its identity, gets the required access, and pushes the image. Absolutely no anonymous uploads allowed here.
And Harbor isn't just a simple storage bucket. It's essentially a layered fortress. Harbor Core, which is the central REST API, manages the strict user authentication. Then, a PostgreSQL database checks the access policies to make sure Jenkins is actually allowed to write to that project. Only after that does the Harbor registry manage the image layers. And on top of all that, the Harbor job service runs background vulnerability scans to make sure the image itself is actually safe. All right, section 4, ArgoCD, the GitOps poll. We are reversing the flow with declarative deployments. Instead of Jenkins having admin access to push straight into our live cluster, which honestly is incredibly dangerous, we reverse the flow. For hop 4, ArgoCD sits safely inside the cluster and actively reaches out to CATIA. It pulls CATIA for the deployment manifests using SSH private keys, and those keys are stored incredibly securely as Kubernetes secrets right inside the cluster. You really start to see the stark contrast here. Remember those plain text configs from earlier?
readable by literally any attacker with repo access. But in a GitOps model, we use Kubernetes sealed secrets. They're encrypted specifically for the sealed secrets controller in your cluster. Because they are basically unbreakable outside of that specific cluster, you can safely commit them straight to your Git repositories. ArgoCD also runs a really tight ship internally. User passwords stored as heavily encrypted bcrypt hashes. And while it does use Redis to cache the application state for 24 hours to reduce load, Redis explicitly does not store any credentials. Inside ArgoCD, performance never compromises security. Plus, every piece of internal service-to-service communication happens entirely over encrypted TLS. And finally, Section 5, Safe Deployment in Kubernetes, the final destination. Here is our very last handshake for Hop 5. ArgoCD strictly enforces role-based access control, or RBAC, to update the cluster state. It ensures the application exactly matches what GitHub says it should be. Then, the Kubernetes node agent, the kubelet, takes over. To actually grab the container, the kubelet pulls the image directly from Harbor securely, using dedicated Kubernetes image pull secrets for authentication.
But how do we manage who gets to tell ArgoCD what to do in the first place? We use OIDC, OpenID Connect, combined with RBAC. This links up your centralized identity managers like AWS SSO or Okta with really granular permissions. Admins use this to guarantee that a developer can't just accidentally delete an app that they're only supposed to be viewing.
The official documentation hits the nail on the head here. In ArgoCD, not allowing everyone to do anything is a best practice. That's the essence of least privilege, right? You've got to restrict access tightly. Because if your RBAC policies are loose, this entire secure chain of trust we just built completely falls apart at the very last mile. Which brings us to the ultimate question for you. Is your GitOps pipeline a vulnerable weak link or an unbreakable chain of trust? I challenge you to take a hard look at your infrastructure today. Ensure every single hop, from your developer SSH keys to the webhooks, the container registry passwords, right down to your cluster's image pull secrets and RBAC, requires a strict, unbreakable handshake. Thanks for joining me on this explainer, and I hope you leave today ready to lock down your deployments.